In this video, we will focus on graphs associated with one-dimensional motion. There are three of them: the position time graph, velocity time graph, and acceleration time graph. They are closely related to each other, and they give important information about the motion involved. Let's begin with the position time graph. Let's assume that the object moves along the x-axis. The purpose of this graph is to quantify the change in position of an object with time t as the object moves along the x-axis. Let's assume you have an object and its motion is depicted below. It moves from the origin to the point x1 in 1 second, and then from x1 to x2 in another 1 second, and then followed by from x2 to x3 in another 1 second. Now, how do we plot this movement on the xt graph? So for the first second, the object is at x1. In the second second, it gets to x2. And in the third second, it is at x3. So when you connect these 3 points, you get a curve like that. And the reason why you get the curve like that is that in each second, the distance the particle moves, or the object moves, is a little bit different. The distance the particle moves in each second gets larger and larger and larger, resulting in the curve as shown. Now, what happens if you have a motion of an object as follows? The object moves the same distance each second. So 1 second, 1 second, 1 second, the distance it moves is the same. So if we were to plot the points, it will look like this. So at t equals to 1, it is at x1, t equals to 2 at x2, and t equals to 3, it is at x3. And now when you connect, you get a straight line. So you see how a position time graph can give you a very good picture of how the object moves. Now we look at what the slope of position time graph represents. As you can see, the slope along this graph at different points are different. At time t1, the tangent is steeper, resulting in a larger slope than compared to, let's say, time t2, where the tangent is less steep and therefore a smaller slope. From calculus, we know that slope of this xt graph can be written as dx dt, and from the previous video, we know that dx dt is quite simply the velocity at a particular time, whether t1 or t2. So if you want to calculate the instantaneous velocity of the object at, let's say, t1 seconds, then simply calculate the slope of the graph at t1, and so on. As a further illustration, let's look at the graph shown. Now we'll concentrate on 3 points. Points 1, 2, and 3 is labeled. The slope of the graph at point 1 is positive. So the velocity of this object at time t1 seconds is positive. At point 2, the tangent is flat, so therefore the slope is 0, and the velocity of the object at t2 seconds is 0. And at point 3, the slope of the graph at t3 seconds is negative, so we say that the velocity at t equals to t3 seconds is negative. So this graph represents a motion of an object that starts at x equals to 0, moves to x equals to 5, stops momentarily, and reverses its direction back to the origin. Now let's look at this simple exercise. At t equals to 0, where is the object? So this is the t equals to 0, and the object is obviously at x equals to 3. So it's at the minus side of the x-axis. So x equals to minus 3. Number 2, movement direction at t equals to 1, t equals to 2, and t equals to 3 seconds. At t equals to 1, the slope of this graph is positive, as you can see. So that means the movement direction is along I hat. if it's moving along the x-axis. At t equals to 2 seconds, the slope is 0. That means there is no movement. The object is at rest. At t equals to 3 seconds, the slope is negative, and therefore the object is moving in a minus I hat direction, because that is the direction of the velocity. And part 3, where does the object stop? The object stops where the slope of the xt graph is 0, and that happens here at x equals to 5. And that happens at t equals to 2 seconds. So x equals to 5 is where the object stops. And that happens when t equals to 2 seconds. Next, let's focus on velocity time graph. This graph quantifies change in velocity of an object with time t as the object moves. So the slope of this velocity time graph can be written like that. And we know from a previous video, this is simply the acceleration at a certain time t. The red dotted line is the tangent line of that graph at t equals to t1 seconds. So the slope of that tangent line is indeed the acceleration of the object at t equals to t1 seconds. Now let's look at area under this graph, under the VT graph, let's say between times t1 and t2. What does this shaded region signify? Now, from our previous video that relates position to velocity, we know the two are related through this equation. Mathematically, the shaded region is given by the following integral: lower limit t1, upper limit t2, an integral of v with respect to time. And now we can see that this is quite simply the difference in the coordinate between t2 and t1. So that is the area under this graph, the shaded region means. X at t2 minus x at t1, the difference in the coordinate, is just the displacement of the object as it moves. So area under the graph, under the VT graph, is the displacement of the object between the two times. Let's look at this following example for a minute. Before we calculate the distance traveled in 7 seconds, let's look at the slopes. Between t equals to 0 to t equals to 2 seconds, the slope here of this VT graph is 10 over 2, which is 5 meter per second squared. So the acceleration is positive, and it's 5 meter per second squared. Between 2 to 5 seconds, the slope is 0, so the acceleration is 0 meter per second squared. The object is moving with constant velocity. That's what it means. And lastly, from 5 to 7 seconds, the slope is negative, and it's given by minus 6 over 2, which is minus 3 meter per second squared. So that indicates deceleration. The object is slowing down between 5 to 7 seconds. Now note, the object doesn't come to rest anywhere between 0 to 7 seconds. So it's always moving the right hand side of the x-axis. So the distance traveled is the same as the displacement in this case. So that means all we have to do is to figure out the areas under the graph. So we can divide up the graph into 3 segments. The first one is shaded in red. So that area is the area of the triangle. So that's going to be half times 2 times 10, which is 10. Since distance or displacement is measured in meters, so that's 10 meters. Next is the area of the rectangle that's shaded in blue. And this is given by 3 times 10, which is 30 meters. And finally, the green region, the area of which can be calculated like this. There are two regions, triangle and a rectangle. So the triangle area is half times 2 times 6, and then plus the area of the rectangle, which is 2 times 4. So you get 6 plus 8, which is 14 meters. So overall, the distance traveled in 7 seconds is 54 meters, as shown. Finally, let's look at the area under the acceleration time graph. So what does this area signify? The area, as we can write from calculus, is an integral of the acceleration function with respect to time, and we know it is quite simply the velocity. So now the integral with the limits t1 and t2 will give you the difference in the velocity at two different times. So the area under the graph, the shaded region in red, represents the difference in the velocity between the two times, vt2 minus vt1. So in this exercise, we are given an AT graph. We are told that at 0 seconds, the velocity is 8 meters per second, positive. So what is the velocity of this object at t equals to 6 seconds? Now we know the difference in the velocity at between 6 seconds and 0 seconds is given by the area under the graph. So all we have to do is to calculate the area under the graph. Now this area is an area of the triangle. It's half times 8 times 4, which is 16 meters per second. Now this area here is a negative area, so it's half times 2 times minus 4, so it's minus 4 meters per second. So the total area under the graph is 16 minus 4, which is 12 meters per second. Now we are told that the velocity at 0 seconds is 8 meters per second. And we want to compute the velocity at 6 seconds. So that means the velocity at 6 seconds is 12 plus 8, which is 20 meters per second. That's the answer to the question. So to summarize, for the xt graph, the position time graph, the slope represents the velocity at a particular time t. For a velocity time graph, the slope represents the acceleration of the object at a certain time t, and the area under the velocity time graph represents displacement between those two times. For the acceleration time graph, the area under the acceleration time graph between any two times represents the change in velocity between those two times. I hope you find today's video useful. We shall discuss kinematics in the next video. Have a great day, and thanks for watching.